All right, so I'm going to go through a few examples of writing an inverse of an exponential function. So we're going to be turning these exponential functions into logs. Like I said, I'm going to do a few of them. I'm going to save a few for us to do tomorrow during class as well. So I'll start with number 2. So currently it says g of x equals 3 to the x. I'm going to go ahead and rewrite it with y. And then I'm going to flip the x and the y. Now, when we convert from an exponential to a logarithm, the exponential is on the left and the single values on the right. So I'm going to go ahead and flip these around. So I'm going to have 3 to the y equals x. And then I'm going to go ahead and convert. So I'm going to have log base 3 of x equals y. So there's my little loggy froggy. So log base 3 of x equals y. And then when I write this as an inverse, I'm going to put f negative 1 of x equals log base 3 of x. So I just replaced that y that we had with f negative 1 of x. So that's the inverse of that exponential function. Now, just kind of relating this back to change of base, this is a perfectly fine answer, but you could possibly, as a multiple choice, you could see it written using the change of base, where it would be the common log, so log of x divided by log of 3. So technically, this is the same thing as this. So just being able to recognize that if it was a multiple choice question. All right, the next one I'm going to do is number 3. So number 3 is 2.5x plus 8. And I'm going to go ahead and first write it as y equals. So y equals 2.5 to the x plus 8. I'm going to switch my x and y. So I'll have x equals 2.5y plus 8. Now, I need to get the exponential by itself. So I'm going to move the 8 to the other side, and I'll do that by subtracting. So I'll end up with x minus 8 equals 2.5 to the y. And then I'm going to flip it around and rewrite it in with the exponential on the left. So I'll have 2.5 to the y equals x minus 8. So now I'm going to use loggy froggy. Now this right here is going to be grouped together and it'll go inside the logarithm. So I'm going to have log base 2.5 of x minus 8 equals y. So I'm going to go ahead and write that. Log base 2.5. So 2.5 is my base. The argument, so the thing inside the logarithm, is going to be x minus 8. Usually when it's two terms, they'll put parentheses around it. So that's going to be inside my logarithm. And then it's going to be equal to y. And if I rewrite that with the inverse notation, so I'll have f negative 1 of x equals log base 2.5 of x minus 8. So that is the inverse of that exponential. And then the last one I'm going to try, I'm going to save number 5 for us to do together, just because it has multiple steps there. And I'm going to go ahead and do number 6. So I'm going to go ahead and rewrite number 6 with y equals 1/2 times 4 to the x. Then I'm going to switch my x and y. So x equals 1/2 4 to the x. Now I need to get rid of this 1/2, so I have the exponential by itself. So I'm going to multiply both sides by 2. So I'll end up with 2x equals 4 to the x. Whoops, where did my y go? I'm sorry, y'all. I switched it and kept the x there. That should definitely be a y once I switch. So I should have a y up here. Sorry about that. And now I'm going to convert. I'm going to flip them around, get my exponential on the left. So I'll have 4 to the y equals 2x. And now I'm going to convert it to a logarithm. So log base 4 of 2x equals y. There's my little loggy froggy. So log base 4 of 2x equals y. And then in inverse notation, this would be f negative 1 of x equals log base 4 of 2x. So that would be the inverse there. So I'm going to box all those in. Okay, as those answer choices. And again, this one could be written like this or like this. Technically, any of the ones could be split up into that ratio, like these are. Any of the answer choices could look like that instead. The other three I'll do with you tomorrow at the beginning of class. Now, for this example, we're going to find the inverse of p of x equals 2 to the x minus 6. So I'm going to go ahead and rewrite it as y equals 2 to the x minus 6. Now I'm going to flip the x and y. I'm going to put the exponential on the left. And then I'm going to convert it to a logarithm. So I'll have log base 2 of x equals y minus 6. So there's my loggy froggy. So log base 2 of x equals y minus 6. And I'm still solving for y, so I am going to have to add 6 to both sides. Now that 6 is going to be outside of the logarithm. So I'll end up with y equals log base 2 of x. And then I'll add 6 to that. So that 6 is outside the logarithm. It's not inside the logarithm. And then the final answer there, f negative 1 of x equals log base 2 of x plus 6. So that is the inverse of that function. Now, the very last thing it says, Andre claims that 2 to the x minus 6 can be rewritten as p of x equals 2 to the x divided by 2 to the 6. Explain why this is true. So this is interesting. It's just kind of relating it back to exponent rules. Whenever you have subtraction in exponents, that relates back to division, because if you are dividing with exponents and you have like bases, you would subtract your exponents. So these two things are equal. So p to the x, if you had 2 to the x over 2 to the 6, if I want to combine these into 1, 2, I would take and subtract my exponents. So it is the same thing, because it will be the same thing as 2 to the x minus 6. And that's nothing you need to know like for this unit. It's just something that's important to know about exponents and exponent rules, just in general. And then I want to kind of tie this back to like another example that's dealing with like numbers as the exponents. So think about back to if you had something like this and you were trying to combine those x's together, you would subtract the exponents. This would be the same thing as y to the x, or y equals x to the 6 minus 4, which would be the same as y equals x squared. So it's kind of that same idea that if you're dividing, you would subtract the exponents. Or if you see subtraction in exponents, then technically you've divided at some point. So it's just kind of tying that back to those exponent rules. And again, it's just kind of pulling an exponent rule problem, not necessarily related directly to what we were doing with the logarithms. All right, and the last few questions are going to be going from logarithms to exponentials. And I'm going to do a couple of these, and I'll save one of them to do together in class tomorrow. So I'm going to do number 1 and number 3, and I'll save number 2 for us to do together. So I'm going to go ahead and rewrite it with y. And then I'm going to switch my x and y. I keep forgetting to change the x. Okay, then I'm going to flip and put my logarithm on the left. So just like when we were converting the exponential to the logarithm, we wanted the exponential on the left. The same thing is true for our logarithm. So I'm going to rewrite this as log base 2 of y minus 3 equals x. And now I'm going to convert. So I'm going to have 2 to the x equals y minus 3. There's my loggy froggy. So I'm going to rewrite it as 2 to the x equals y minus 3. And then to solve for y, I'm going to add 3 to the other side. So I'll end up with y equals 2 to the x plus 3. And then I'm going to write that in inverse notation. Okay, as 2 to the x plus 3. And then number 3, I'm going to try this one as well. So I'm going to go ahead and rewrite this as y equals ln of 3x. And then I'm going to flip my x and my y. Now, in order to convert a natural log to an exponential, you have to identify the base here, and the base is e on that natural log. So it would be ln of e of 3y equals x. And now I'm going to go ahead and convert. So I'll have e to the x equals 3y. So e to the x equals 3y. And then to solve for y, I'm going to divide by 3. So I'll get y equals e to the x over 3. And then if I put that in inverse notation, that would be my final answer. Okay. One of the things we're going to do tomorrow is I am going to graph some of these together so you can see the relationship between the graphs. Just important for you to kind of understand. I know we graphed one earlier today, but just to kind of reiterate that relationship, like what we graphed here, where they would be reflective across that line, y equals x right here. So I will graph a few of these tomorrow, and I will do the last few examples. So I'll do the 3 on this slide and the last one here on this last slide. All right, see you in the morning.